this whiteboard and I'm cutting the y1. Imagine that I've carried this whiteboard and I'm trying to get the trace when it's gonna hit in y1. It will hit in a straight line. Okay? So that's the trace that you will see, which is 3x minus y when z equal to 0. Also, there is the contour of a surface, or as we will see shortly, what's called the level curve that we will be interested in down the road. For example, for this, let me see, for this sphere, if I cut it, okay, by a plane parallel to z equal to 0, let's say at z equal to 2, what's gonna be? What's gonna happen if I cut this sphere at z equal to 2? If I do so, I will have a circle, but with a diameter less than the diameter at the center or at the basic side at pi 1. This is really very simple. If I want to find this, all I have to do is to substitute instead of z by 2. So your equation is going to be 2 to the power of 2 over 16, which is going to be a quarter. Move it to the other side, 1 minus 1 over 4, which is going to be 3/4. Divide on the 3/4. Then your equation will be x squared over 12 plus y squared over 12 equal to 1, which is a smaller circle. Of course, Judy, the greatest circle from all of them is once you hit z equal to 0. And you will have x squared over 16, y squared over 16 equal to 1. And it makes sense also. This sphere, it is at the origin. So this is the biggest circle. As long as you are moving upward, the circles is gonna grow smaller and smaller. As you can see, that's the greatest circle, and that's the smallest one from the graph. Okay, really very good. And as I told you, that's if we put z equal to 0, that's the circle at z equal to 2, and that's the circle at z equal to 0. Okay, now I will talk about another shape, which is the ellipsoid. What's the ellipsoid? The ellipsoid is exactly like the sphere. It's exactly like the sphere. But it's like a sphere and you put your leg on it. So the dimension of the radiuses are going to be different. Okay? So that's the shape actually of an ellipse, where you have the radius on the x direction is 4, the radius on the y direction is 3, and the radius on the z direction is 25. That's the shape of representing that equation, okay? Which is an equation of an ellipsoid. So what's the name again?
Ellipsoid.
Ellipsoid. Yes, it's really very simple. Okay, if I make just a minor change, I need you to focus with me now. If I make just a smaller change, instead of having this positive sign, I will leave the equation exactly the same, but I will change this positive sign to be negative sign. So I have two positive signs and one negative sign. What's going to be? In this case, I will have what's called a hyperparaboloid of one sheet. A hyperparaboloid of one sheet. I'm expecting to see x squared over a certain value plus y squared over b squared minus z squared over some number equal to 1. Remark that in order to draw this hyperparaboloid of one sheet, بص كده Mr. You said that's the x, that's the y, and that's the z. Y, x, and z. I will go to the x with negative sign, which from this equation it's the zx. I will draw a hyperbola around the zx. This is my hyperbola. Okay, any problems? I choose the z because it has a negative sign. Then I will do an ellipse on the upper wing and another ellipse on the bottom wing. That's the shape that you will see of a hyperparaboloid of one sheet. It's very, very simple. As you can see, it's something like this. Okay? It's really very close to طبلة. Okay? اهو ده الشيب بتاع الهايبربارابولويد of one sheet. ماشي؟ هو له شكلين، انا دايما بيفكرني بيه. الطبلة البلدي بس تبقى يعني الاورينتال درام بتاعنا، بس يبقى التو اوبننجز دايما زي بعض، يعني نفس السايز، ودايما ده الاختلاف عن الاور طبله. اوكي، لان الثانيه كبيره، اللي قدام كبير بس اللي ورا ايه اصغر شويه. ماشي اوكي. وبرده لها حاجه ثانيه، عارف انت الحجر بتاع الشيشه او حاجه زي كده، شيشه ايوه الحجر ده بيحطوا فيه، هو شبه ده بالظبط. ده الشيب بتاعه لو انت طلعت من فوق. تمام يا جميل. ده الشيب لو انا طلعت منين؟ من فوق. يعني لو انا جيت رحت طاير لفوق وبصيت من هنا، ده الشيب اللي انا هشوفه. طبعا يسمى without those plans، من غير البلانز دي يعني، بس البلانز دي محطوطه دي المين بلانز. اوكي اي مشاكل؟ طبعا جميل جدا البارابولا او الهايبر بارابولويد اوف فانشين. ايه بقى جماله؟ ان الهايبر بارابولويد لما تقطعه خلاف ما تخرطه. يعني ايه لما تقطعه خلاف ما تخرطه؟ يعني ده لو انت بتخرطه كده هيديلك اليبسات.
يعني ايه تخرطه؟
زي الخيار، ده خيار بتخرطه كده.
انت فاهم يعني تخرطه؟
عارف
لا مش شرط. او لو انت عندك خيار تخرطه كده. ماشي صح؟
قطعته صغيره.
احنا هنقطعه صغير. لو انت جيت تقطعه كده هيديك ايه؟ اليبسات. طيب لو انت بقى بتقطعه بالطول هيديلك هايبربولس. يعني لو انا جيت اهو ده شكله، بص البلان ده بيقطعه ازاي؟ هايبربولس. يجي لك تاني من الايكويشن. لو انا بخرطه يعني بحط الزد بصفر او بفاليو، يبقى لو انا حطيت زد بصفر ده مش موجود. لو ده مش موجود دي اتس ايكويشن اوف اول البس. انا عارف ان 2 دايمنشن
البس قصدي
البس. طيب لو ده مش موجود
البس برضه
لا اتس ان ايكويشن اوف هايبربولا، انا كنت بره. ولو ده مش موجود اتس ان ايكويشن اوف هايبربولا. يبقى انا لو انا خرطته هيديلك اليبس، قطعته هيديلك ايه؟ هايبربولس. اوكي ماشي حلو قوي. ده الشكل طبعا بتاعه، واللي انا قلته لك بتاع التخريط والتقطيع مكتوبه. طبعا that's x square over a square y square over b square minus z square over c square equal 1. ده الشكل بتاع الهايبر بارابولويد فانشين. In the plane z it's equal to b, it's an ellipse. In plane y equal to q it's a hyperbola. يعني ايه plane y equal to q؟ يعني لو انا شلت الواي دي وحطيت q يبقى equation of a hyperbola. لو شلت الزد دي وحطيت p يبقى equation of an ellipse and so on. Okay? So this is what's all about hyperparaboloid function. Actually, there is another shape from the main equation of the ellipsoid. Okay? Which is the same equation of the hyperparaboloid of one sheet, but instead of having positive 1, it is negative 1. It is negative 1. Or you have two axes with negative sign and one axis with positive sign. I may have two positive axes and one negative axis. Negative axis, okay? One negative axis. This case is going to be a hyperparaboloid function. Now, if I have two axes with negative and two axes with negative sign and one axis with positive sign, you will, in this case, you will have a hyperparaboloid of two sheet. Or it's exactly the equation of a hyperparaboloid of one sheet, but instead of equal to positive 1, it's equal to negative 1. طيب, the shape of the hyperparaboloid of two sheets, it's really very simple, which is like a paraboloid looking upward and another one looking downward. That's the shape of a hyperparaboloid of two sheet. So you will have حتة فوق وحتة فين؟ تحت. This is the shape of a hyperparaboloid of two sheet, guys. Of course, all the relations that we spoke about is valid. Miss Judy, what if I cut it with by 1? Let's try. If I want to cut it with by 1, I will insert z equal to 0. Am I right? So this guy is going to disappear. If this makes sense, can you please read it?
X squared over 16 plus y squared over 9 equal negative 1.
Is this even possible?
No.
Why?
عشان نيجاتيف مفيش نيجاتيف ريتس.
مفيش ايه؟
نيجاتيف ريتس.
عشان كلامك مظبوط partially عشان ما فيش values to the power of 2 added together and equal negative 1
اه
or negative sign.
أي
So it's an imaginary, it is an imaginary circle. Actually it doesn't exist and it makes sense. بص كده لما اجي في z بيساوي 0 ده z بيساوي 0 شايف z بيساوي 0 دي بيعمل ايه هنا؟ Is it cutting anything? طيب when it's gonna cut something has a meaning. It will cut a something has a meaning if you use z greater than 5 in this case. Because the distance from the origin here to the vertex is 5 units. So if you use z equal to 5, you will have x squared plus y squared over 9 equal negative 1, which is gonna cancel this negative 1, and you will have x squared over 16 plus y squared over 9 equal 0, which is the point, the vertex. But if you cut by z greater than 5, you will start receiving your ellipses. معايا Mr. Isaac? قشطة. That's an equation of a cone. يا ترى what's the difference between hyperparaboloid of one sheet, of two sheet, and a cone? This is the equation of a cone. Can you tell me what's the difference?
زيرو
Equal 0, not equal to 1, not equal to negative 1, but it's equal to 0. And the x in the middle is going to be the negative. If I want to draw it, it's really, very simple. All I have to do, this is the x, y, and z. So that's the z. I will draw two lines like this around the origin. Then I will make a circle like that and a circle or an ellipse like this one. Now I have the shape of a cone. That's the shape of the cone. معايا مس جودي؟ طيب جميل جدا. That's the shape of a cone. طبعا ده شكله برضه from another angle as you can see. And that's the shape of just only the above cone. So this is the cone above the by one, and this is from Lisbon PDFs. Okay, so that's the shape of an elliptic cone. We call it an elliptic cone. Okay, that's the shape as you can see. Also, there is the equation of an elliptic paraboloid. elliptic paraboloid. يا ترى شكل الelliptic paraboloid ده يبقى عامل ازاي؟ بص كده مس جودي. It is x squared over a squared, y squared over b squared equals z. So I will have two axes with power 2, and one of the axes with no power. And in this case, you will have, as you can see, x squared over 4, y squared over 9 equal to z. In this case, I will go and draw, this is the y, the x, and the z. So that's the y-axis, that's the x-axis, and that's the z. I will go for the x with no square, which is the z-axis. I will look to the sign, Mr. Muhammad. The sign is positive. I will draw a parabola around the z, and then I will do an ellipse, as you can see. And that's the shape of elliptic paraboloid. It's called an elliptic. Are you with me? It's called an elliptic paraboloid. That's the shape of an elliptic paraboloid. I hope it is in front of you as you can see. That's also the shape if I moved the principal plans يا محمد in order to imagine the shape of an elliptic paraboloid. طيب يا Miss Judy, what's the difference between this equation and if the equation, the sign in the middle is negative? In such a case, we will be talking about a hyperbolic paraboloid. Can you see it? Hyperbolic paraboloid. Hyperbolic paraboloid. Or what's called a horse seat, or as you will see. Here, I will start also, look, Ms. Judy, this is x, y, and z. So that's the y-axis, that's the x-axis, and that's the z-axis. I will go around the positive z-axis, since this value is positive. And I will do a parabola, as you can see. And then from this side, I will do a parabola. And from that side, I will do another parabola, as you can see. I will connect these two wings together. And then I will connect these two wings also, this is the dotted line, embrace the other or the line in behind. It's like the saddle horse. It's something like a saddle horse. So they usually call it also saddle horse. So it's a hyperbolic paraboloid or what's called a saddle horse. Also, once more, here is the shape of the hyperbolic paraboloid, as you can see. طبعا Mr. Muhammad remarked that those wings are not stopping. They are extending up to infinity from each side. From down and from each side, left and right, that's gonna be the shape. Also, that's the shape from another angle. This is the shape for around the Z, also in another angle for you to see the shape of this paraboloid. I'm sorry. Also, you have an elliptic cylinder, and the elliptic cylinder زي عمر هو اللي يخش الامتحان. The elliptic cylinder, it's also one of the interesting equations because the elliptic cylinder is x squared over 4 plus y squared over 9 equal 1. And one of you will ask me, well, I don't feel comfortable around this equation. It's an x squared over 4 plus y squared over 9 equal 1. Does it remind you of something? Isn't this an equation of an ellipse? So, but if I'm talking about an equation of an ellipse in 3D, it is a cylinder, an elliptic cylinder. That's the shape of the cylinder. So, as you see, this is the ellipse in 2 dimensions, but if I'm talking in 3 dimensions, it also represents a cylinder. And that's the shape of your cylinder, as you can see. There is also what is called a hyperbolic cylinder, which is going to be the equation, yes, you are right, a hyperbola, but in 3 dimensions, not in 2 dimensions. If I'm in 3 dimensions and the equation is a hyperbola, it means a hyperbolic cylinder. Can you imagine the shape? Can you imagine the shape of this hyperbolic cylinder? It's like you have a tube. معايا Judy, if you have a tube, okay, so I'm holding a tube, okay, between my fingers, and if I cut it, ya Muhammad, vertically, I have 2 halves of this tube. Then I will move this half in the back of the other half. Can you imagine the shape? So this bar is continuous and that bar is continuous. It's like 2 parabolas. This is why it's called a hyperbolic cylinder. And finally, this is what's called a parabolic cylinder. That's the shape of a parabolic cylinder. Parabolic cylinder, once more. And the equation is for a parabola. The equation is for a parabola. But in 3D, it's going to be a paraboloid, as I told you, a parabolic cylinder. Parabolic cylinder. Those are the shapes of everything. Now I will go, that's enough for an idea about curves and surfaces and everything as you would see down the road. Now I have a strong background about the shape of equations, about the quadratics, about a parabola, about a sphere, about an ellipsoid. All I need from you is to imagine the shape, to link it to the graph, and to imagine if I'm cutting it, what's gonna be the shape. If I'm cutting longitudinally or in the long direction, what's gonna be the shape, okay? Very good. Now I'm going to talk in specific about the functions of one variable. And I'm interested at the time being in identifying the domain. Once we do the domain in those functions, I will continue with the domains of functions in several variables. Once I'm talking about a domain, it's like the domain represents the condition for a function to work. So once more, what's the domain? The domain is the condition for a certain function to work, or to have a meaning, or to be defined. That's the meaning of a domain. Now, Mr. You said you will have problems, and you will need to think. The major thing that I will have to put in mind, as you, I'm sure you know in your foundation and the previous years, okay? I usually, when I'm searching for domain, I should watch that I don't have a denominator equal 0, because I know all denominators doesn't equal to 0. And also I knew that if I have an even radical, then what's inside this radical should be greater than or equal to 0. And also, if I have logarithmic function, the argument of the logarithmic function must be greater than 0. And of course, for logarithmatics, I may have the len, which is a log but for base e, or having log for base a. Those are the two general cases. Also, I need you to be familiar with those symbols. R stand for the set of real numbers from negative infinity to positive infinity. R positive, which means the positive side from the real numbers. Not considering 0, so 0 is not with you. I'm talking about the positive part. So just greater than 0, so 0 is open up to infinity. R negative would represent the negative side of your real numbers. So from from negative infinity up to 0. And of course, Princess Judy, if you look to this guy, it is R positive with 0. So as you can see, the 0 is closed and the positive infinity is open, which means it's the positive side, including the origin. تمام؟ حلو كويس. طيب, for polynomials, the domain is going to be every value of x, because polynomials doesn't have nominators or even radicals or something like this. But if I have an even radical, then I will have a condition that x must be greater than or equal to 0, which can be simply represented by r positive and 0. If I have f of x equal a to the power of x, like 2 to the power of x, e to the power of x, it's an exponential function. So now the domain is going to be r, on all the set of real numbers. If I have, so no problem whatsoever with this guy. If I have log x for base a, if I have log x for base a, okay, I know that the x value must be greater than 0. So x belongs to r positive. Do you understand what I'm saying? That's the definition of the domain, which is the condition for this function to be valid. Miss Julie, I know you like tricks and puzzles. Can you please tell me what's the domain of this function? In this case, I have more than one condition. In this case, I have a condition for the denominator, also a condition for the denominator. So I have how many conditions? 2 conditions. The first condition is to have x minus 2 is greater than or equal to 0. So yes, Mr. Muhammad, if I try to solve this equation, which is y equal to the root of x minus 2 divided by x squared minus 9. So the first thing to keep in mind is that you will have the inequality x minus 2 must be greater than or equal to 0, which will imply that what's going to make the denominator, the denominator to work is x values greater than or equal to 2. The second thing that you should keep in mind that x squared minus 9 shouldn't equal to 0, which leads to x squared shouldn't equal to 9, which leads to you should extract both positive 3 and negative 3 from out of your domain. So when I'm talking about my domain, it's going to be x belongs to from negative infinity up to negative 2. Okay? Negative 2 is closed. Union from 2 up to positive infinity. Okay? So those are the intervals. بس خلي بالك, except the values at negative 3 and 3. So now I'm writing the domain of this function. As you can see, the x squared minus 9 doesn't equal to 0. So as I told you just a second, the negative 3 I'm sorry. I have the condition that x must be greater than or equal to positive 2. So this guy is not correct. Just from 2 up to infinity, I will have just only to take positive 3. So, which is correct, of course. So, now I'm telling you, if you have more than one case of the above mix and the match and get the common domain satisfying all the conditions according to the case given, as you will see. Now, in those cases, I have y equal to the square root of 9 minus bx squared, which is a function running from R to R. If you look to the second function, Judy, you will find that f runs from x and y, and you will have just only one output, which is a function in several variables. It's a function in several variables. And also for number C, how to get the domain. The domain, in case of functions in several variables, should be the condition, the intersection of the conditions involved. So, for the first problem, which is root of 9 minus bx squared, now you are familiar with this equation. Any one of you can tell me what's the equation of representing, or what's the shape representing this guy? Y equal root 9 minus bx squared. Any ideas?
Doing?
Square both sides.
Yeah.
I'm talking about the shape first.
Oh.
Let's square both sides. If I square both sides, then I will have y squared 9 minus,
X squared.
which is y squared plus b of an x squared equal 9. Doesn't this represent something? اللي هو
ايه؟
أكيد بتزيد صوت.
ellipse. صح؟
أيوة.
لأن عندك الراديوسز is not equal. ماشي؟ طب if b equal to 1 is going to be a circle. صح؟ بس he didn't talk about b. So I will consider it as a general case, it's an ellipse. If I want to get the condition for this function to work, of course, the ellipse or the parabola, the ellipse or the circle, it's a closed shape, it's not a function. It's an equation representing a shape. To be a function, I will have to have, as you know, every value of x should have just only one value in y. This is why the semicircle is a function. You understand what I'm saying? The semicircle is a function. But a full circle is not a function. It's just a relation representing the circle. Okay? So, anyhow, I will just put 9 minus bx squared greater than or equal to 0, Mr. Yusuf, which leads to in the 9 is greater than or equal bx squared. That's relative to, am I talking right, Miss Judy? If I wrote bx squared is greater than or equal to 9, is it correct?
Same thing.
Okay, which means x squared is greater than or equal 9 over b. That's x is less than أيوة or equal 3 over root b, and the greater than or equal negative 3 over root b. And yes, it makes sense. In this case, here we go. This is y 9 minus bx squared. This is an equation of an ellipse or a circle. If b equal to 1, as you can see, x belongs to this interval, and that's the shape of your circle, and that's the details of the evaluation. If I want to problem number b, look to problem number b. I have a condition that the denominators shouldn't equal to 0. When the denominator will equal to 0, when y equal to 2x. So I should avoid when y equal to 2x. طبعا, if I'm talking about a function in 2 dimension, then I'm talking about something in 3 dimension. What I'm trying to say, if y equal x squared, in this case I have from R into R. Am I right? From R into R, it means the shape will be in 2 dimension. This is important, Judy. So that's the shape of this equation. I'm moving from R into R. So from one dimension into one dimension. Add them together. So the shape will appear in two dimensions. If I'm talking, خلي بالك, from R2 into R, now I'm talking in how many dimension? 3 dim. R2 plus the result. فاهمني? This is why this shape will appear to you, but in how many dimensions? In 3 dimensions. The values of x and y will represent the z component. So I can say that z equal to x of y minus 2x. So the values of x divided by y minus 2x actually will represent the z coordinate. Okay? طبعا, which means, so the function is defined in every way, but not on the line y equal to 2x. This is why Monsieur Muhammad, and I've also wrote this comment to you in here. For z equal f of y or x, we will depend on using values in the plane of xy to get the corresponding value of z, which map from 2D into 3D. Okay? So this is to connect them. So this is x, y, and z. This is the line y equal to x, and at this line I can't find any substitutions, so the shape in 3D is going to be like this. The shape is going to be moving down and up around y equal to 2x, because the function is not defined at y equal to 2 over x. If I push you more for a function like this one, this is really very nice. Can you state the conditions, Mr. Muhammad? The condition for this function to be true?
Y should not be 0.
Yeah, this is number 1. Y shouldn't equal to 0. Then x should be greater than 0. Then ln x over the rest of values of y, I should guarantee that they should be greater than 0. صح؟ يبقى إذا بقى هبدأ. Also, we still have a real valued function. So putting the conditions all together, I will put them all together. Okay, first, y doesn't equal to 0. It's a denominator, say Muhammad said. To protect the denominator, and then ln x will lead to x is greater than 0. That's the second condition. The third one is to be sure that ln x over y is positive. Never been 0, and never been a negative number. I already knew that this value is not going to be 0, but I need to put the conditions. So I will put the condition. If y is greater than 0, if y is greater than 0, so I should be sure that ln x is greater than 0. Ln x to be greater than 0, it means x is greater than 1. So that's the first domain. X is greater than 1. Under the condition, y is also greater than 0. Type, if y is less than 0, which means negative, the logarithmic function will deliver negative values if the x values between 0 and 1. أي كريم طبعا كلامك صح، لأن طبعا اللين بيبقى ده شكله. ده الجراف بتاع اللين function. ده هنا positive 1. لذلك for the period from 0 to 1, the result بتاعت Linux is going to be negative values. Are you with me? But above 1, the results of the Linux will be positive values. This is why you said you will find Linux is greater than 0, which leads to x is greater than 1, and under the condition y also is greater than 0. In this case, you will divide positive over positive, the result will be positive. So you are securing the outside then. Also, if in case y is negative, the value of x should be between 0 and 1. Because 0 and 1 on the denominator will guarantee that the sign will be negative. And the negative over negative is going to be positive. This is what I'm telling you about the depth of following up your equations and determining which are the parts that you should take or leave from your domain. So now I can sum it all up. That's the domain of f, x, and y belongs to R2 such that x is greater than 1 while y is greater than 0, or x is greater is between 0 and 1, while y is less than 0. That's the shape of the of y equal, I'm sorry, of the function len equal to len x over y under all of these conditions. Okay, the domain of real functions. Another problems on the domain. Here he is giving you f of x equal to len of root x squared minus 4 divided by the x minus 3 negative 1. And of course, the problems that you will face in your exams somewhat near to this, guys. So if I look to this problem, how many conditions do I have? Huh?
2.
I guess
Domain
3.
3.
The first, what's beneath the square root or the radical should be greater than or equal to 0. And what's inside the radical should be greater than 0. So putting them all together, so x squared minus 4 should be greater than 0. And I should try to choose the values of x that will make e to the power of x minus 3 never equal to positive 1, which means that the denominator will be safe. And those are the steps that I'm going to do. X belongs to R such that x squared minus 4 is greater than or equal to 0, talking about the radical, and x squared minus 4 is greater than 0. I'm talking about both of them and the condition for the len. And I'm talking about the denominator shouldn't equal to 0, which can be put easily in this form. That's x squared minus 4 should be greater than 0, and the e to the power of x minus 3 doesn't equal to 1. Any ideas how to solve this equation, Mr. Karim? How to solve this equation,
x when x equal 3.
Huh?
When x equal 3.
When x is equal to 3? Yes. طبعا Karim, you have plenty of options you can use. I can use len for both sides. So I can apply len e to the power of x minus 3 equal to len 1. Are you with me? And in this case, this is going to be 0, and that's going